Good afternoon, everybody. Welcome to Physics IGCSE, and we are doing some of the end of chapter questions that are related to Hooke's law. Please try and work through questions 11, 12 and 15 at the end of the chapter. I'm going to work through question 12 with you after you have had a go at it. So that will clear up any problems. So please pause the video and attempt the questions now. And then once you've done that, come back and we will discuss it. Okay, so question 12 gives you a table with the load that is put on a spring in newtons, 0, 10. The table is in 10, is written 10.0, 20.0, but I've just written 10, 20, and 30, 40, 50, 60, 70 newtons. Okay, and the length of the spring is starts off at 3.200. That's 3.2, and this is in meters. With the 10 Newton, it then extends to 3.207 meters. With the 20 Newton, it extends to 3.215 meters, and so on. Okay, so these are clumsy numbers to work with, so we need to simplify it. It's going to help if you have already done the mathematics section on standard notation or scientific notation, because we're going to use some of that here. That is the length. So this was the original length of the spring, 3.2. Here was no load, so there's no extension. Here there was 10. The difference is 0.007. Every time we just subtract the 3.2 from each one of these, and then we will get the difference, which is actually the extension. So that's why I've just taken out the 3.2 and put in zeros, so 0.007, 0.015, 0.022, and so on. Okay? So this looks, we've got to put this load on as the independent variable is coming on the horizontal axis, this load. And this extension we're going to put on the vertical axis. This is the dependent variable. So we will discuss the drawing of the graph as we go along. But I'm going to now remove this table so that we can go on to the... Okay, question A, determine the extension. This has been done here. It's just a subtraction. Question B, draw an extension load graph. Right, now we're going to do that. So I've used the page with blocks on. If you have graph paper, that's fine. But the page with blocks works out like this. And divide your page up into 5 blocks. Okay? So first draw yourself a vertical axis and a horizontal axis. Give yourself a bit of space at the bottom to write the label for that, which is load in newtons. And here, write extension in meters. Okay, so I'm going to show you what we do now. So we count 5 blocks, 5 blocks, 5 blocks, 5 blocks. So we end up with, at the bottom of the page, having 1, 2, 3, 4, 5 sections of 5 blocks. So it's going to look something like this. 1, 2, 3, 4, 5. So each one of these is 5 little blocks. And how did I arrive at that? I said to myself, I looked at the load and I said, oh, it's going from 0 to 70. So we want to work in tens, so let's just make 100. Okay, so that's why I've got 1, 2, 3, 4, 5. And if we take 100 and divide it into 5, each one is 20. So this is going to be 20, 40, 60, 80, 100 newtons. Right. And then I'm going to I divided the vertical axis up into 1, 2, 3, 4, 5, 6, 7. 7 lots of 5 blocks. 1, 2, 3, 4, 5, 6, and 7. Okay? And it's also going, now, we've got funny numbers here. 0,007, 0,015. We can put these on here, but if you look at these numbers, I can see 7, 15, 22, 30, 42, 55. And all that is those numbers, if we take 7 and we divide it by 1,000, we get 0.007. So 0,007, for example, is the same as 7 times 10 to the minus 3. So 7 times 10 to the minus 3, here's our decimal point. We move it 3 back, 1, 2, 3. It eventually ends up over here. So we can just work here in whole numbers of 7, 15, 22 and so on, and we just write here times 10 to the minus 3. So that we know whatever we read here is times 10 to the minus 3, and that's the actual number. So now we're going to mark these, and again we've got up to 70. 1, 2, 3, 4, 5, 6, 7. So we can mark it 10, 20, 30, 40, 50, 60, 70. Alright, now it's easy. Once you've done that, it's just a question of reading it off. So 0 is 0, but 10 is going to be 7. We've got to estimate 10 as being halfway from 0 to 20. And we've got to estimate 7 as being halfway, because here you're going to estimate 5s. This is going to be 5, this is going to be 15, this is going to be 25, in the middle, yeah, 35, and so on. So we've got to estimate where 7 is and where 10 is. Here's 10 and there's 7. So your 7 is going to be approximately here. I'm making crosses because I'm used to that. Although they tell you in the book they want you to make a dot with a circle around. Okay? But I don't want to try that just yet because I'm still just doing what I know. So here we have 15, 20 is 15. 20 is here. 20 is 15, so that's here. Okay. And we just go and plot them off. 30 is 22. Where's 30? Sorry, this is 20. 20 is 15. 30 is 22. You can count your blocks on your paper. You've got more blocks than I have. So you'll be able to plot it much more accurately. That was 30. Next one is 40 is 30. 40 is 30. And 50 is halfway, is 50 is 42. 42. And 60 is 55. 55. Halfway between 50 and 60. Now you take your ruler to answer the next question. Determine the extension produced by a load of 25 newtons. In fact, you actually, we still have to draw the graph, okay? So what's happening here is if you put your ruler here, And where it is straight, you draw a straight line. So in fact, this turns out to be straight. And what happens here, it tends to curve a bit. So you can join the dots, or you can draw a curve freehand. I prefer to draw a curve freehand. I'll show you just now how. But now from the graph they ask us to determine the extension produced by a load of 25 newtons. 25, this is 30. 25 is halfway between 20 and 30. What is the load produced by 25 newtons? If you like, you can measure it with a ruler and find exactly halfway, make a little dot, go straight up there, and then come this way. And it actually turns out to be about 18. It turns out to be, I get 18. So a load of 20 is going to give you an extension of 18, but it's not 18 meters, it's 18 times 10 to the minus 3. Don't forget that. You have to reconvert it back to meters. So we're going to move the 3 back 1, 2, 3, and that is equal to 0,018 meters, which is 18 thousandths of a meter. Okay? Then they want to determine the load at the limit of proportionality. This is directly proportional where it's a straight line, or it's proportional. Here it's not proportional anymore because the line is starting to turn. So you put your ruler over here, you've already done that, make sure this is straight. Where it's not straight anymore, that is the limit of proportionality, and I've determined that to be 30. You can see here, 30. Okay, so the rest of the questions I leave for you to do. Question 11 you shouldn't have a problem with, and question 15 is fairly similar. So I think you've had quite a good bit of practice now, and yeah, wish you luck and see you next time.